the problem we're going to use in order to investigate these measures of dispersion. A veterinarian in an animal hospital recorded the following lifespans of selected Labrador retrievers to the nearest year: 7, 9, 11, 15, 18, and 12. Find the range and the standard deviation of these ages. Well, we can find the range by looking at the highest value, which is 18, and subtracting from it the lowest value, which is 7, to give us a value of 11. And so we say that the range of values is 11. The standard deviation, as you saw before, has a formula that's a little bit more complicated to work with. Let's rewrite this data set to give us some room. We have a 7, 9, 11, 15, 18, and 12. Now, we could reorder this and put the 12 right after the 11 if you'd like, or you can actually work with it this way. What we're going to do now is we're going to remember that what we have to have for the standard deviation is equal to the square root of the sum of x minus x bar squared, and that sum divided by n minus 1. Let's identify some things that we're going to need. Well, obviously, we're going to have x bar. So let's calculate that first. X bar is going to equal the sum of all of my values divided by the number of values. Here, we're going to add together all of these values to give us a sum of 72. We're going to divide that by the number of values. There are 6 different values, and we come up with then 12 as our result. So that's going to be the answer that we'll use for x bar. Our n value, as we saw, is 6. The x is different depending on which value we're working with. To evaluate this more easily, we're going to set up a chart. And in this chart, I'm going to have a column where I'm going to put down my data value. I'm going to have a column where I'll take my data value and subtract from it the mean. That would give us that x minus x bar. And then, once I get that answer, I'll look at that data minus the mean squared. So let's start. We'll have our value of 7. If we look at the difference between that data value and the mean, we have a difference of negative 5. And if we square that, we come up with 25. Let's look at 9. Difference between that and 12 is negative 3. Squaring gives us 9. We have a value of 11. Difference is negative 1. Squaring gives us 1. 15, we have a difference of 3. Squaring gives us 9. 18, we have a difference of 6. Squaring gives us 36. We have our data value of 12. Difference is 0. Squaring 0 gives us 0. Now, when we put it into this chart format, we can then add together this last column. And if we take this summation, we end up with 36 plus 10, which is 46, plus another 34 to give us a sum of 80. So we're going to have S equals the square root of, and in the numerator, this summation will be 80. We'll be dividing that by n minus 1, which is going to be 5. And now evaluating, we have S equals the square root of 16, and S then is equal to 4. What we say then is that the standard deviation is equal to 4. This gives us an idea of the spread of the data about the mean. On average, the data is 4 units away from the mean.